A properly configured VTOL drone takes off vertically from almost any terrain before tilting its forward rotors to transition into high-speed airplane mode. While the physical airframe provides the mechanical capability for flight, the software defines how the vehicle interprets its environment. Ground Control is the primary tool used to program the flight controller and verify that all onboard systems are communicating correctly. For this guide, we are configuring the SP7007, an airframe that utilizes a quad-rotor layout for hover and a rear-mounted motor for forward efficiency. Before applying power to the electronics, you must remove all propellers. This is a critical safety step to prevent an accidental motor start during the configuration process. An uncalibrated drone can be unpredictable in flight. By following a structured setup, we ensure the autopilot acts as a reliable, autonomous tool. To begin, connect the Pixhawk flight controller to your computer using a direct USB connection. In Ground Control, select the current stable PX4 flight stack firmware for reliable flight features. Once loaded, specify the vehicle's exact physical layout by selecting the standard VTOL group and the airframe matching the SP7007 configuration. Apply these settings and wait for the hardware to reboot. A successful installation is typically signaled by an audible chime from the flight controller. This initial flash provides the controller with the mathematical models required to manage the transition between hovering and forward flight. We now calibrate the compass. This allows the drone to understand its heading relative to magnetic north, but it is highly sensitive to interference from metal surfaces or nearby electronics. If possible, use a wireless telemetry radio instead of a USB cable during this step. USB connections can produce local magnetic fields that distort the sensor readings. Physically rotate the drone around all three axes to map the magnetic field. The interface uses clear color coding. Red indicates an uncalibrated axis, yellow means stay still, and green confirms that the specific orientation is complete. Next is the gyroscope calibration. Place the drone on a perfectly level surface and ensure there is no movement or vibration nearby while the software samples the data. For the accelerometer, the software will guide you through several fixed orientations. Hold the drone steady in each position until the prompt tells you to move to the next. These calibrations provide the autopilot with an accurate understanding of gravity and orientation, which prevents the drone from drifting or losing its heading during flight. On a VTOL aircraft, the airspeed sensor is a vital component for fixed-wing safety. Unlike a multicopter, a fixed-wing aircraft relies on the air moving over its wings to generate lift. The airspeed sensor is the only way the autopilot can detect a stall, which can happen even if the drone's ground speed is high. To calibrate the sensor, we first need to establish a zero-speed baseline. Cup your hands over the pitot tube to block any ambient wind. Be careful not to cover the static ports on the sides of the tube, as this will result in an incorrect offset. After starting the calibration in the software, blow gently into the tip of the tube to complete the cycle. Now we move to the radio control setup. This process maps the physical sticks and switches on your transmitter to specific commands in the flight controller. Assign a switch to position mode. This is the safest setting for manual flight, as it uses GPS and sensors to maintain the drone's location when the sticks are centered. Next, assign a switch to return mode. This acts as a primary safety feature, allowing the drone to autonomously fly back to its home point and land if you lose orientation. Finally, map the VTOL transition switch. This gives you direct manual control over when the drone switches from multi-copter hover to forward airplane flight. Mapping these switches ensures that the pilot has direct control over the drone's automated flight functions. Check the main dashboard in Ground Control. A successful configuration is indicated by a clean status panel with no sensor errors or warnings. For the final check, connect the main 6S battery to the power distribution board to power the full system, including the motors. With propellers removed, perform an arming test. Verify all 4 VTOL motors and the rear pusher motor respond correctly to transmitter inputs. The core sensors and flight controls are now operational. This concludes the initial software setup, allowing you to move on to ESC calibration and the configuration of your safety failsafes.